Hello friends, welcome to engineering tutorial. Today we are going to discuss about a concept which is related to basic electronics or the analog electronics part. So today we are going to discuss about transistors, some of the basic introductory concepts about transistors. Okay, so let's get started. So first we must understand what is a transistor. Okay, so a transistor is an electronic device consisting of two PN junctions. Okay, it consists of two PN junctions which is formed by a process or technique called as sandwiching, the sandwiching process. So in this process of sandwiching, a p-type semiconductor is sandwiched in between two n-type semiconductors, or a n-type semiconductor is sandwiched in between two p-type semiconductors. So we have a p-type semiconductor which is placed in between two n-type semiconductors on top and bottom, which leads to an NPN transistor, and a n-type semiconductor placed in between two p-type semiconductors on top and bottom, leading to a PNP transistor. So we have two types of transistors formed because of the sandwiching technique. The first one is the NPN transistor and the second one is the PNP transistors. Both have their own characteristic features and are used accordingly in various processes depending upon those features. So we have the transistors which can be divided into two categories depending upon their mode of fabrication. The first one is the NPN transistor and the second one is the PNP transistors. Okay. Now the fabrication of the transistors. Now as I said, there are two ways in which a transistor can be fabricated. Okay, so first is the fabrication of NPN transistors. So as I said before, in NPN transistor, a p-type semiconductor is placed in between two n-type semiconductors. Now the process by which these semiconductors are joined together is called as sandwiching. So it's just like a sandwich. Okay, this is the p-type semiconductor which is sandwiched in between two n-type semiconductors, and from each semiconductor portion a terminal is taken out. Now we will discuss about what these terminals are called, and another thing which you would have noticed here is that the area of each of the semiconductor portions are different, and why is that we will also discuss in the upcoming stages. Okay, for the time being you just understand that an NPN transistor is fabricated by placing a p-type semiconductor in between two n-type semiconductors, and a PNP transistor is fabricated by placing an n-type semiconductor in between two p-type semiconductors, and from each semiconductor portions, from each semiconductor block, one terminal is taken out. Okay, so here we have is the fabrication technique of both NPN and PNP transistors. Now we will discuss about the terminals of the transistor, or what the terminals, the three terminals which are taken from each semiconductor block, what are they called. So let us say we have a transistor, whether it is a PNP or NPN. Now the three terminals which are taken out from each of these semiconductor block are: first the emitter terminal, which is written in short form as E. In the middle we have the base terminal, which is written in short form as B, and the third one is the collector terminal, which is written in short form as C. So we have three terminals, okay, three terminals which are taken from the three individual semiconductor blocks, which are the emitter E, base B, and collector C. Now you would have noticed that the base has the least area occupancy. The emitter has slightly more area than the base, but it is less than that of the collector, and the collector has the maximum area. Now why it is done in this fashion, we will discuss in the working of the transistor. Okay, so we have the three terminals emitter E, base B, and collector C, which are taken from the three separate individual semiconductor blocks of a transistor. Okay, now let us describe each of the three transistor terminals, okay, and their functions and their characteristic features. So first, the emitter. So the emitter is one semiconductor block, whether it is an NPN or PNP transistor. It is basically it is in a conventional fashion, it is always shown towards the left or the left side, but it can be also on the right side. That is a way of drawing diagram. Normally it is shown in the left side. So the main function of the emitter region or the emitter block is to supply charge carriers. Now what are these charge carriers? Those are electrons in case of an n-type semiconductor and holes in case of a p-type semiconductor. So the main function of the emitter is to supply charge carriers towards the base. Okay. Now the emitter is always forward biased with respect to base. What is forward bias? So if a p-type semiconductor is connected to the positive terminal of the supply voltage and the n-type semiconductor is connected to the negative terminal, it is called as forward bias. And what is reverse biased? If the opposite thing is done, so that if the p-type is connected to the negative terminal and the n-type is connected to the positive terminal of the supply voltage, it is called as reverse bias. So the emitter terminal is always forward bias. So if it is an NPN transistor, the emitter terminal will always be connected to the negative terminal, and if it is a PNP transistor, the emitter terminal will always be connected to the positive terminal of the supply voltage. So why it is forward bias? So that maximum number of charge carriers can be supplied towards the base terminal and then to the collector terminal. Now the emitter is heavily doped, means that maximum impurity is given to the emitter side, so that more number of charge carriers can be generated. Now please you can check out my video related to fabrication of p-type and n-type semiconductors, which is available in my YouTube channel, so that you understand these concepts of p-type and n-type semiconductors, the process of doping and all of these in a better way. So please check out that video. I have described about the various techniques of the fabrication of p-type, n-type semiconductors, the process of doping intrinsic, extrinsic semiconductors. So it will be very helpful to you so that you understand these concepts in a better way. Okay. The emitter is heavily doped and has moderate surface area. It means that the surface area of emitter is more than that of the base, but less than that of the collector. Okay. So this is all about the characteristic features of emitter. Then we have is the base, which is the middle section of the transistor. So the base actually forms two PN junctions, one with the emitter and the other with the collector, regardless of whether it is a PNP or a NPN transistor. One characteristic feature of the transistor is that the emitter base junction or the input junction, which is normally taken, is always forward biased, and as a result of that it offers a low resistance path to the charge carriers, whereas the output junction or the collector base junction is reverse biased, and therefore it offers very high resistance to the charge carriers. Okay. Now the various concepts of forward bias and reverse bias also you can check out in my video related to semiconductor diodes in my YouTube channel, where I have discussed in detail what is forward biased, what is reverse biased, and all these things. So please check out that video in my YouTube channel in basic electronics section. So we have the emitter base junction always forward biased and the collector base junction always reverse biased. The base is lightly doped, means it is least doped in the transistor. The doping level or the impurity injection level is minimum, and also the surface area of the base is minimum. It is less than that of the emitter and the collector. So this is the characteristic feature of the base terminal or the base section of the transistor. Now last but not the least is the collector terminal or the collector section. Now it is a section which is located on the other extreme of the transistor. Now its main function is to collect the charge carriers which are supplied by the emitter, which pass through the base terminal and then to the collector. Now what the collector does is that it removes the charge carriers from the collector base junction, so that maximum number of charge carriers, whether it is electrons in case of NPN transistor or holes in case of PNP transistor, from the emitter is reaching towards the collector. In ideal cases, 95% of the electrons or holes from the emitter reaches the collector. The remaining 5% is lost in electron hole combination process in the base region. Okay. So the collector is moderately doped, means that the doping level of the collector is more than that of the base section but less than that of the emitter section, and it has the largest area. Now why the surface area of the collector is more? Because it has to collect a large number of charge carriers. As a result of that, a large amount of heat is generated in the collector section. So in order for efficient heat dissipation, the collector area is deliberately made large for efficient heat dissipation, because it has to collect the charge carriers, which leads to generation of heat. So it is a preventive measure for efficient heat dissipation. For that purpose, the collector is of large surface area. So these are the characteristic features of the individual terminals, that is the emitter, base and collector of the transistor. So here are the characteristics of the individual terminals written in bullet points. So first we have is the emitter. So these are the characteristics. It is heavily doped, means maximum impurity injection. Its function is to supply charge carriers towards the base and then to the collector. Its surface area is moderate, it means it is more than that of the base but less than that of the collector, and it is always forward biased with respect to base. Now the middle section, base, the base terminal, the base section. Now it is lightly doped, means the doping level is minimum as compared to emitter and collector. its surface area is minimum. The emitter base junction is always forward biased, which is the input junction, and the collector base junction, which is normally the output junction, is always reverse biased. As a result of this, the emitter base junction has least resistance and the collector base junction has maximum resistance. Now, in the base section, the electron hole recombination takes place and a small amount of current called as base current flows because of that. We will discuss those things in detail in the working of the transistor section. Okay. Next is the collector. So, the doping level of collector is moderate, it is more than that of base, but less than that of emitter. Its function is to collect charge carriers and to remove charge carriers from the collector base junction, and its surface area is maximum for efficient heat dissipation. So, these are some of the bullet points related to the characteristic features of the transistor terminals. Next is the symbol of a transistor. Okay. This is the symbol of a transistor. First we have is the Npn transistor. This section is the base of the transistor, the middle section. This portion or this part with the arrowhead is the emitter terminal. Okay, always remember, in the transistor symbol, the one with the arrowhead denotes the emitter. It's the easiest way to remember. And the one with the flat portion like this is the base, and the other portion, the other part, this is the collector. Now, the direction of the arrowhead gives us the direction of the emitter current. Okay, the direction of the arrowhead gives us the direction of flow of the emitter current. In the NPN transistor, the arrowhead is pointed outwards, whereas in the PNP transistor, the arrowhead is pointed inwards towards the base. Here the arrowhead is outwards, it is pointing away from the base in NPN, but in PNP the arrowhead is towards the base. As a result of that, it also, the emitter current is also in this direction. Okay, so this is the symbol of NPN and PNP transistor. Now, this is the base current and collector current. Another thing to remember is that in NPN transistor, the base currents and collector currents IC and IB are directed towards the transistor and the emitter current is directed away from the transistor. Whereas in PNP transistor, the base and collector currents are directed away from the transistor and the emitter current is directed towards the transistor. So, if we apply Kirchhoff's current law here, we will know that the emitter current is actually the summation of the base and collector current. Okay, and the collector current is nearly 95% of the emitter current, because some amount of current is lost in the base section because of electron hole recombination. Okay, so here we have again the NPN transistor, the symbol, the one with the arrowhead is the emitter, the flat portion the base, and this is the collector. The arrowhead is pointed away from the base in NPN and it denotes the direction of the emitter current. The base and collector currents are directed towards the transistor, whereas in PNP the arrowhead is pointed towards the base and also the emitter current is flowing towards the transistor, and the base and collector current flow away from the transistor. So, if we apply Kirchhoff's current law KCL, the emitter current is the summation of base and collector currents, IE is equal to IB plus IC. So, here we have discussed some of the basic concepts related to transistors, the various fabrication techniques, and the terminals, their characteristic features, and the symbol of transistor. Now, in my upcoming video, I will be discussing about the working principle of the NPN and PNP transistor and various other concepts related to transistors. So please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day. Thank you.